Remember that databases are tools for data storage. As with any tool, you need it specified and configured correctly for it to be of maximum value. Databases are configured specifically to the task at hand and the data that are going to be stored within it, and so the first step will always be understanding what is required of the database. Generically, we call these requirements. Database requirements boil down to two things. First, what data we're going to keep in our database, and second, how those data relate to each other. Let's consider a toy example that I might want to consider for this class. I have students, and each student takes 3 exams. So the data that I have are students and exams. I also know that they're related to each other in the sense that each student takes 3 exams. In a very short example like this, it's trivial to conceptualize what a database might look like just based off of my saying it. But when we scale this up, it becomes more difficult. What about when we consider that I have 2 sections of the same class, and that students also submit homework and prep quizzes? Students are grouped up with each other. Here, we want to be able to shorthand these database requirements in such a way that's immediately readable to the database users. This is where entity relationship diagramming comes in. Entity relationship diagrams, which I'll call ER diagrams when I speak and ERDs when I write, use symbology to draw a map of the database. This map isn't meant to be detailed enough for people who are in the process of using the database, but rather communicate the basic structure and requirements quickly. Crucially, the diagram aspect makes it considerably easier to read than a list of text requirements. What we're going to be doing for the next several days is learning how to take requirements that have been listed out in text and convert them into an ER diagram. Let's look at some of the components of an ER diagram now. All ER diagrams are made up of 4 components: entities, relationships, attributes, and cardinalities. I'll cover each in their own section, but first let's discuss what they represent at a high level. Entities can be thought of as nouns: people, places, and things. Where entities are nouns, relationships are similar to verbs. Relations connect 2 entities together. Attributes are adjectives that modify the entity's nouns, or in some cases, adverbs that modify the relationship's verb. Finally, cardinalities don't really neatly map onto any part of speech, but rather dictate how many of one entity is going to relate to how many of another. It's important to note that there are no canonical notational schemes for ER diagrams, but rather ER diagrams are going to be combinations of these 4 components in every case. So while I'll be using the notation that's used in the UKICH book, do note that there are other notational schemes that you might encounter in your career. First, let's talk about entities. Entities represent the nouns on ER diagrams and are represented in our diagrams with rectangles with uppercase labels. If I know that my database is going to involve student records, I'd want to have a student entity. Let's consider another noun that we might want to keep track of: exams. We'll represent that with a rectangle and label it exam. It's important to note that with ER diagrams, we're concerned with the entity in the abstract. So if I have a student entity, it's not going to matter to me who the specific students are at this point. What specific facets of students and exams we're going to keep track of are covered by attributes. So let's cover these now. Attributes represent the adjectives that describe entities' nouns. Or in the abstract, it tells me what I know about each noun. Attributes are represented with ovals. So we know I have a class of students, but on its own, this isn't very helpful. What information do I want to record about each student? This is where attributes come in. Since entities are abstract in nature, I need to specify this in advance. So let's say each student has a name, a student ID number, and a birthday. I'm going to specify each of these on the diagram in their own oval, and I'm going to draw a line connecting these ovals to the entity. Each attribute will be connected to exactly one entity. You never see attributes without an entity, nor will you see an attribute attached to 2 or more entities. We also have exams. So let's say this class has 3 exams: exam 1, exam 2, and exam 3. In this case, I'm going to group them all together as exams, but then have an attribute specify exactly which exam this is. So let's call this exam number. I'm also going to specify a score. What I'm not going to specify is the student who took the exam and earned that score. For that, we're going to use relationships. So let's look at that now. Relationships represent the verbs on ER diagrams, or more specifically, how the entities, or nouns, interact with each other. We're going to be dealing with relationships that have exactly 2 sides in all cases, though both of these sides may be the same entity. For now, let's put a pin in that. Relationships are represented with wide diamonds and have 2 lines outward, one to each side of the relationship. So while we have a student entity and an exam entity, and we know that students take exams, we're going to want to have a relationship diamond, which we'll name takes, and connect the diamond on one side to student and one side to exam. Remember, we're just trying to document how the various aspects that we want to keep track of relate to each other, and so don't overthink the technical details of how this might work just yet. So we have our first three building blocks, but we're missing the quantity of how these two entities relate to each other. How many students work on each exam? How many exams does each student take? Right now, we don't have that information, and for that, we need to use cardinalities. Cardinalities, unlike the other four building blocks, don't neatly represent a part of speech, nor are they directly represented within a database. They tend to be somewhat more difficult to grok, so don't feel lost if you don't get it the first time. It's important to note that we're not representing exact amounts, but rather we're choosing between two options each for two questions about the minimum and the maximum numbers involved. So ultimately there are only four possible choices. But we need to bear in mind that each of the two entities are going to have their own cardinality to the relationship. First, let's discuss maximums. What we're interested in is whether the maximum number of relations to an entity is 1, or if it's more than 1. If it can't be fewer than 1 because then there's no relationship. A maximum of 1 is represented with a single hash mark, and a maximum of more than 1, or many, is represented with a crow's foot. Many in this case is doing a heavy lift. It could mean a maximum of 2, or it could mean a maximum of infinity. As will make some more sense in Chapter 3, the number is less important than whether the maximum is 1 or if it's not. We also have two questions for minimums. The minimum number of representations is either 0 or it's not 0. Put another way, it's either optional or it's mandatory. If it's optional, we represent that with an oval, and if it's mandatory, we represent it with a hash mark. These marks are placed next to the entity. The maximum always goes closest to the entity box, and the minimum goes next to that on the side closest to the relationship diamond. We read cardinalities in a specific way. We go source entity to relationship to cardinality to destination entity. So students take 3, which is to say mandatory many, exams. So we read student takes at least 1 and at most many exams. Going the opposite way, exams are taken by at least 1 and at most 1 student. The cardinality indicators that are attached to the entity are counterintuitively not indicative of the entity's cardinality itself. The cardinality also dictates the type of relationship, namely the maximum cardinality, and here we have 3 possible choices. First, we have one-to-one relationships, which means that the maximum cardinality on each side is 1. It doesn't say anything about the minimum cardinality, so one or both sides may be optional, or indeed neither. If one side has a maximum of 1 and the other side has a maximum of many, we call this a 1-to-m relationship. When we're talking about the relationship type, we're not interested in what side is 1 and what side is many, but rather that one side is 1 and that one side is many. Again, we don't have any interest in what the minimum cardinalities are. Finally, we have relationships which are many to many. We call these m-to-n relationships. This is by convention, and to be honest, I'm not sure why it's not m to m, but at this point we have bigger things to worry about, right?